Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my previous video, I was actually discussing the exercise questions which were there in the 4th chapter of 9th standard science subject. So coming to the 8th question in this particular exercise, there they have asked to explain atomic number, atomic mass number, isotopes and isobars with an example, and also you should give the applications of isotopes as well. So the first topic which you have to explain here is atomic number. So what do you mean by atomic number? Atomic number is either the number of electrons or protons which are there in a particular element. So that can be the atomic number. For example, if I consider helium as my example, at this particular position if I write a number, then that will be the atomic number of that particular element. So this is actually atomic number which is denoted as Z, and in this position if you write A, that is actually the atomic mass number, which is the sum of number of protons present in the nucleus and number of neutrons present in that particular nucleus. So here we will concentrate on atomic number. So what is the atomic number of helium? Atomic number of helium is 2. That means 2 electrons are there in helium and 2 protons are there in the nucleus of that particular helium. Similarly, if I define atomic mass number, so atomic mass number is actually the number of nucleons present in the nucleus. So what do you mean by nucleons? One is proton and the other is neutron. So how many protons are there and how many neutrons are there? So total subatomic particles which are present in that particular nucleus, that can be the mass number of that particular element. So if I consider the same example of helium, so now we are actually discussing atomic mass number. So this particular A denotes atomic mass number. So what is the atomic mass number of helium? So A is equal to 4. That is, here 2 protons are there and 2 neutrons are there. So how to calculate number of neutrons? A minus Z, number of neutrons present in that particular element. So now how many number of neutrons are there and how many number of protons are there? If you sum up them, you will get the atomic mass number of that particular element. So there are so many elements present in the periodic table. So every element you can take and you can give it as an example for explaining atomic number and atomic mass number. So for helium, atomic number will be 2 and atomic mass number will be 4. So coming to the next point which they have given in this question is that you have to explain isotopes and isobars as well. So what do you mean by isotopes? I have explained isotopes and isobars in my previous videos. You can refer those videos for better understanding of isotopes and isobars. So isotopes are elements which have same atomic number but different mass number will be there. That is, there will be variation in neutron numbers, because in isotopes atomic number will be same. That means number of electrons and number of protons are fixed because atomic numbers are same. But when there is increment of neutrons in that particular isotopes, then atomic mass number changes, because subatomic particles which are there inside nucleus will go on increasing because of increase in neutron number. So for example, if I consider hydrogen, hydrogen has 3 isotopes. One is protium, the other is deuterium, and the third one is tritium. So if you consider protium, so protium is the majority isotope of hydrogen. That means more percentage, that is almost more than 99% of hydrogen exists in the form of protium, where 1 electron will be there and 1 proton will be there in this particular protium, but only 0 neutrons will be there. So now if you consider atomic mass number of this particular protium, here you can see 1 electron is there and 1 proton is there. So atomic number will be equal to 1. But when you consider atomic mass number, then you have to consider number of neutrons and number of protons. So what is number of protons? That is 1. And what is number of neutrons? That is 0. So 1 plus 0 is 1. So atomic mass number also remains as 1. But whereas if you consider deuterium, here atomic number will be same, that is Z will be always 1 only, but atomic mass number will be equal to 2 for deuterium. That means here 1 proton is there and 1 neutron is there. So that's why the atomic mass number is 2 for deuterium, but atomic number is still 1. So that's why this element is also hydrogen only, but this is an isotope of hydrogen. Here protium is almost more than 99% hydrogen exists as protium isotope. Less than 1% hydrogen exists as deuterium and tritium in the nature. So now if you consider tritium, here also atomic number will be 1, but atomic mass number will be 3. That is, 1 proton will be there, but 2 neutrons will be there. So that's why here you can clearly see in hydrogen, if you consider example of hydrogen, hydrogen exists in 3 isotopes. One is protium, deuterium and tritium. And protium, deuterium and tritium, all these 3 isotopes of hydrogen will be having atomic number 1. That is, all these isotopes of hydrogen will have 1 electron and 1 proton. But protium will have 0 neutrons, deuterium will have 1 neutron, tritium will have 2 neutrons. So that's why atomic mass number will go on vary in these 3 isotopes. So protium will have 1 as its atomic mass number, deuterium will have 2 as its atomic mass number, tritium will have 3 as its atomic mass number. So coming to isobars, if you consider isobars, isobars are those elements when you compare 2 different elements where atomic number of those 2 elements will be different but mass number will be same. Whereas in isotopes, atomic number was same but atomic mass number was different. But in isobars, atomic mass numbers will be same but atomic numbers will be different. So now if you consider calcium and argon as your example, so calcium has atomic number 20 and argon has atomic number 18. So now you can see atomic number of calcium and argon is different. So that's why elemental characteristics of calcium is different and argon will be different. But if you consider mass number of calcium and argon, mass number is same, that is 40. Both calcium and argon has atomic mass number 40. So that shows here in this 40, 20 protons will be there because atomic number is 20. So 20 neutrons will be there. So 20 plus 20 is 40. But whereas in argon, 18 protons are there, but 22 neutrons will be there. So 18 plus 22, again it will be 40 only. So this shows atomic mass number is same, but atomic numbers are different. That is, calcium is having 20 as its atomic number and argon is having 18 as its atomic number. But mass number of calcium and argon are same. So these kind of elements, if you consider, then they are known as isobars. So calcium 20 and argon 18 can be known as isobars. In the same question, they have asked the application of isotopes. So what are all the applications of isotopes? Uranium isotope can be used as fuel. So uranium isotope can be used as fuel in nuclear reactors. Uranium isotope can act as fuel in nuclear reactors. So this is one application of isotopes. And the next application of isotopes is that here cobalt, like if you are considering cobalt as your example, so one of the isotope of cobalt can be used in treatment of cancer. So if you consider isotope of iodine, iodine isotope can be used for treatment of goiter. So goiter is one of the disease which can be observed in human beings by the lack of iodine present in their body. So this you will be learning in your biology chapters. So one of the iodine isotope will be helpful in treating this particular goiter disease. Coming to the ninth question, in Na+, you will be having complete filled K shell and completely filled L shell. So you have to explain this. So now if you just consider Na, that is sodium, in sodium the atomic number of sodium is 11. So that means 11 electrons will be there. So now according to electronic configuration, if this is nucleus of a sodium atom, so the first n is equal to 1 energy level, that is the first discrete orbit of sodium will be containing 2 electrons in it. And if you consider the next discrete orbit of sodium, then in this particular orbit, this is actually n is equal to 2 energy level. So we know that 2n square number of electrons are possible in a particular discrete energy level. So if you consider n is equal to 1 energy level, that is the first discrete orbit, that is the K shell, then in that K shell n is equal to 1, and if you substitute this 1 in this formula, it will be 2 of 1 square. So that is 2. That means maximum 2 electrons are possible in K shell. Now if you consider L shell, that is the n is equal to 2 energy level. Here n will be 2. So if you substitute 2 in this particular formula, 2 into 2 whole square will be there. So 2 whole square is 4. So 2 into 4 will be 8. So 8 electrons are possible in the second energy level. So that is in the second discrete orbit 8 electrons will be possible. So 1, 2, 3, 4, 5, 6, 7, 8. So total 8 electrons are possible in L shell. So in K shell only 2 electrons are possible. So now 2 plus 8 will be equal to 10. So that means in K shell you have 2 electrons. In L shell you have 8 electrons. So total 10 electrons are there in K shell and L shell of sodium atom. But the total atomic number of sodium is 11. So if you consider atomic number of sodium, that is 11. So here one more electron should be there. So that one more electron will go to M shell. So one electron will be there in M shell. But now here in this question they have asked Na plus. So here you can see this particular sodium has positive charge on it. That means it has lost one electron. One proton is there in the nucleus. That is 11 protons will be there in the nucleus of sodium atom. But 11 electrons are not there in that particular Na plus atom, because one electron has knocked off from that sodium atom. So that means here 11 protons will be there, but only 10 electrons will be there. So that's why, because of loss of one electron, this particular positive charge is there, because one extra proton is there in Na plus. So that's why this particular sodium has positive charge on it. So now only 10 electrons are there. Hence K shell can be filled with 2 electrons, L shell can be filled with 8 electrons, and here you can see 2 plus 8 is 10. That means there is no requirement of M shell at all, because whatever the electron, one electron which was there in M shell has already got knocked off from this particular sodium. So that's why K shell is completely filled with 2 electrons, L shell is completely filled with 8 electrons, and one more electron which was there in sodium has got knocked off and it has got positive charge. That means it has lost one electron. So that's why out of 10 electrons, all these 10 electrons have completely filled K shell and L shell. That is 2 electrons have completely filled in K shell and 8 electrons are completely filled in L shell. That means L shell is completely filled and K shell is also completely filled, and all 10 electrons of Na plus are occupying K shell and L shell. So this is how you have to explain, and you have to mention K shell, L shell, like how many electrons can be present in K shell and how many electrons can be present in L shell. So 2 electrons can be present in K shell, 8 electrons can be present in L shell, because this Na plus ion has only 10 electrons in it. Now coming to the 10th question, here you have to calculate the average atomic mass of bromine. So this I have explained for chlorine in my previous video when I was actually explaining about isotopes. Now in this particular exercise they have given bromine. So, and they have also given the percentage of abundance of the isotopes of bromine. So here they have given 2 isotopes of bromine. So one isotope of bromine has 79 as its atomic mass number and 35 as its atomic number. So abundance of this particular bromine isotope in nature is 49.7%. So if you consider the second isotope of bromine, that particular second isotope of bromine will be having same atomic number, that is 35, but mass number is 81 in this particular second isotope of bromine. And the abundance of this second isotope of bromine in the nature is 50.3%. So now based on this percentage values, you have to calculate the average atomic mass of bromine by considering both the isotopes of bromine. So one particular isotope of bromine has 79 atomic mass and the other bromine isotope has 81 as its atomic mass. You cannot take average between 79 and 81 because percentage difference is there. Here if bromine 79 was there 50% and even bromine 81 is also there as 50% in nature, then you can easily take average between 79 and 81. So here you can see atomic mass number is 79 and here it is 81. So you can directly take average of 79 and 81 if 50% was there for these two isotopes. But here bromine 79 exists as 49.7% and bromine 81 exists as 50.3%. That is not exactly equal to 50%. So you have to calculate average atomic mass by using one particular formula. So average atomic mass of bromine. So we are calculating average atomic mass. So here one isotope of bromine is 79. So that you should multiply with 49.7 percentage. So when you multiply with 49.7 percentage, it will be 49.7 by 100. Plus you should add this with the second isotope of bromine, that is bromine 81. How much atomic mass is there for bromine 81? 81 is the atomic mass number of bromine 81, and the percentage of abundance of this particular bromine in nature is 50.3%. So you should multiply this with 50.3%. So 50.3% will be 50.3 divided by 100. So now if you calculate this, 39.263 plus 40.743. That is, when you make 79 into 49.7 divided by 100, you will get 39.263. So 39.263 plus, here when you take second isotope, here it has 50.3% abundance. So when you calculate 81 into 50.3 divided by 100, you will get 40.743. So 40.743 will be there. So when you add this particular 39.263 with 40.743, you will get 80.006. So the average atomic mass number of bromine 79 isotope and bromine 81 isotope. So if you are considering these two isotopes of bromine, then the average atomic mass number of bromine will be 80.006. This is actually average atomic mass number of bromine, where bromine exists in two isotopes, where one isotope has 79 as its mass number and other isotope has 81 as its mass number. So when you calculate average atomic mass of both the isotopes for bromine, then the answer which you are getting here is 80.006. So 80.006 is the average atomic mass number of bromine when you consider both the isotopes of bromine. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics related to 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.